USV submarine detection depends on more than sonar payloads. An anti-submarine warfare unmanned surface vehicle must maintain heading, track accuracy, and sensor alignment while carrying acoustic, magnetic, inertial, and positioning systems. In long-duration patrols, detection quality depends on navigation stability, low onboard interference, and reliable performance in GPS-denied conditions. Submarine detection is not only a sensor problem, it is also a persistence problem. Naval operators need enough time on station to detect, correlate, and monitor low-signature contacts across a patrol area. A USV supports that mission by maintaining presence in choke points, harbor approaches, and defensive patrol lanes for extended periods. Surface drones extend sensing coverage with lower crew exposure than continuous crewed patrols. That matters in contested waters and endurance-heavy surveillance tasks. Multiple USVs can also be distributed across one operating area, supporting wider coverage, overlapping sectors, and improved revisit rate. A submarine detection USV depends on several sensing functions working together. Acoustic sensing is usually the primary detection method, whether through passive hydrophones, compact active sonar, or a towed array. Magnetic sensing can help confirm a possible contact. Inertial and heading sensors support dead reckoning, route repeatability, payload alignment, and motion compensation. Effective USV payload integration requires balancing each sensor's function against its installed limitations. Acoustic sensors depend on tow geometry, vessel speed, and low self-noise. Magnetometers are vulnerable to interference from motors, power systems, and structure. IMUs are affected by vibration, bias drift, and thermal conditions. GNSS supports absolute position and timing, but it remains vulnerable to jamming and spoofing. A USV can carry capable payloads and still produce weak results if the navigation solution is unstable. Small heading errors change search geometry. Position uncertainty weakens localization. Attitude instability complicates data correlation. Detection quality depends on navigation quality more than many teams expect. Installed performance matters more than bench performance. A sensor may test well in isolation and behave very differently once mounted on a working vessel. Propulsion systems, power electronics, radios, antennas, and metallic structures can all degrade onboard sensing. The real challenge is not only choosing the right sensors, but ensuring they still perform reliably after installation. A surveillance USV cannot assume continuous satellite navigation. It must maintain patrol routes, preserve lane spacing, and continue reporting contact positions with bounded error during signal disruption. That requires a tightly integrated navigation stack using inertial sensing, magnetic heading, and sensor fusion to maintain patrol continuity. A surface drone does not replace every crewed anti-submarine platform. Its role is narrower and operationally focused. It extends coverage, adds persistence, reduces crew exposure, and contributes sensing nodes to a broader surveillance network. That makes it useful for choke point monitoring, barrier patrols, harbor protection, and forward sensing. Small surface vessels operate under hard limits in size, weight, power, and compute capacity. Every navigation and sensing component competes with propulsion, communications, payload processing, and endurance. That is why low SWaP sensors matter. Compact hardware preserves power budget and internal volume for acoustic processing, communication links, and mission duration. For engineers developing an anti-submarine warfare unmanned surface vehicle, the key question is not only which payloads fit on the platform. The more important question is whether the vessel can preserve sensing quality and navigation accuracy across the full mission. Late in the design cycle, those details often determine whether the system produces usable operational data or intermittent detections with poor localization quality. If your team is building a platform for USV submarine detection, barrier patrol, or harbor surveillance, review the navigation stack as carefully as the payload.